So I'm just going to start from the very beginning. What I'm going to be showing you is running on an operating system called ZOS, and it's not advertised on television or anything, but you all use it every day. Everyone in the world does, and they don't even know it. ZOS is the operating system for the most powerful and heavily used system in the world, sometimes called mainframe. We call it System Z, and you'd be surprised that when you make a phone call, the minutes on your cell phone are counted with a COBOL program on a mainframe. When you make an insurance claim or pay your water bill or buy a car made by a manufacturer, they used COBOL to keep track of the inventory and the manufacturing. And you'd be really amazed at how much COBOL is used by every single large company and entity in the world. And you've heard probably about the fact that all of our unemployment insurance systems for our states are written in COBOL. The U.S. government uses COBOL. Pretty much everyone that has a large number of customers to support. Z is the system. So it's kind of a right out in the open secret. But anyway, so that's ZOS. On ZOS, there are many ways to do work, and one of them is called a job. And so I'm going to show you a job that I wrote, and it's a unit of work in something called batch, where you can execute some work in batches. And so you submit a job, and it runs, and that's like a batch of work. And then you can have thousands of users submitting jobs, and they get queued up and managed by the system, and they have different priorities, and they get run in the right order and kept track of, and each job gets resources to use and cleans up after itself. The operating system cleans up, so there's no chance for things like memory leaks from one user to affect another user. If my job has a memory leak, it all gets cleaned up when my job is done. JCL. JCL is how you write what controls what happens within a job. It stands for Job Control Language, so that's why we needed to know what a job was. And it defines what the job is doing. And some of the things in JCL that I'm going to show you are the exec statement, which is short for execute. That's like run a program, and the exec statement will point to something that you want to run. And then everything needs input and output, files and resources, work areas and things like that. And we use a DD statement, a data definition statement, to tell the job where to get input and output, for example. And then the common terms are sysin, system input, and sysout, system output. So you'll see those as well. In my job, I'm going to compile, link, and run a COBOL program. So what the heck is COBOL? It's a common business-oriented language. And again, this is might be surprising to you, but it's the most used programming language in computer science today in terms of executions per second per day and the amount of work it gets done, which is kind of shocking because everyone's running little programs on their cell phones all day long. But I'll show you a really cool chart about that to compare the usage of like Google search compared to COBOL programs running. COBOL is the most common language on the ZOS operating system. So just like ZOS runs the world, COBOL runs the world as well on ZOS. And then you might have heard people say, well, it's old, it's 60 years old, it's no good anymore. Now, some parts of the language are like 50 years old, like the language C, which is also, I think it's 49 years old or something. But other parts of the COBOL language are less than a year old, especially on the IBM mainframe, the ZOS compiler. We call it Enterprise COBOL for ZOS. And we just added new features late last year, like a UTF-8 or Unicode data type. We had Unicode UTF-16 for many years, but we finally added UTF-8, or AMOD64, which is the ability for a COBOL program to use 64-bit addresses for very, very large chunks of data. Modern COBOL, like from IBM, supports Unicode, object-oriented programming based on the Java model. You can process XML, both parse and generate. You can process JSON. You can write a C function in COBOL. You can write a Java method or define a Java class in COBOL, and Java users of it would have no idea. COBOL can do everything on the mainframe, pretty much, except for some really low-level system programming stuff. So, does anybody use COBOL? Yes, you do. So I love this chart. This is from a transaction monitoring system called CICS, Customer Information Control System. On CICS, there are this chart is a couple years old, but at that time there were 1.1 million KIX transactions every second of every day, all night long, just continuously. In comparison, there are only 59,000 Google searches every second. So when you think of a billion people on the planet doing Google searches on their smartphones, and then compare that to the KIX transactions, it's pretty amazing. It's used so much more than any other kind of system in the world. And I've heard estimates that my friends in KIX land, we pronounce it CICS KIX, the estimates are that 90% of the KIX transactions are written in COBOL. So that means that there's way more COBOL programs running per second than Google searches. So you might not have known that. Okay, let's look at COBOL. COBOL uses very English-like terms in order to be readable. It was designed to be readable by non-programmers. So, for example, at a bank, a manager could look at a COBOL program and see if his programmers are trying to steal money from him, which has actually happened, where they take the hundredths of cents in rounding and truncation cases and siphon them off to their own personal account, and then after a few million transactions, they're rich, and the bank is wondering where this extra money is going. So the manager could read the programs and see if anybody's trying to be sneaky. And they can also see what how the programs are doing, how the business is being run, because the COBOL programs define how businesses run. They're very important artifacts within the company. They're kind of like the company treasure, because the COBOL programs define how the company works, and it's super important for everyone to know how it works, and if they want to change it and make it better, they have to change the COBOL programs. Okay, so COBOL programs are divided up into divisions. There's a data division and a procedure division. The data division defines the data artifacts to be used in the program. In most languages, you would call them variables, but in COBOL, they call them data items. So might be a little bit weird, but I'm so used to it, I don't even think about it. But in the data division, you define your variables for your program. You also define files in case the program is going to do file input-output, or I/O. So we have a file section, and we have a working storage section for work variables. And then we have a procedure division, and that's where the procedural part of the program is written. That's where the executable statements are. And they are in sections, and then within sections you can have paragraphs. So it sounds very English-like, but it's organized in a way that makes it easy to understand and easy to read. For example, if I want to look at the data items defined in a program, I look in one section, whereas other programming languages, data items or variables can be defined all over the program, and so they're not as easy to locate. If I'm getting assigned a program to work on and fix, and I've never seen it before, I would much prefer to have a COBOL program, because I can find out what it's doing much more quickly than if I had a C program. Okay, and then some procedure division statements. I'm going to show you several of these. Move is like move A to B. for assignment, and other languages would just have like A equals B, and B gets assigned into A. Move is very clear which direction it goes, and it's actually extremely powerful. It's kind of subtle, but the move statement in COBOL can convert any data type to any other data type. For example, if I move a character data item, and characters on mainframe are in an encoding called EBCDIC. You might have heard of ASCII, A-S-C-I-I. That's what non-mainframe systems use pretty much, like Windows and Unix. But on mainframe we use EBCDIC, and if I move an EBCDIC character string in an EBCDIC data item to a Unicode data item, the move statement will convert the data type from the EBCDIC to Unicode. And I can convert numeric types to each other. It's super powerful, and you don't even think about it. When you try to do this in other languages is when you really notice how powerful COBOL is. I program in other languages. The compiler is not written in COBOL. It's written in a different language. And I get mixed up sometimes because it's harder to deal with this kind of thing outside of COBOL. And I take it for granted that I can just move that to that, and it'll get converted, and it doesn't in other languages, so you have to manually do things. Okay, so COBOL, like every other language, has if then else, but then we have something unique called evaluate. It's similar to a switch statement in C or a select in PL1, where you can have multiple conditions to select what to do based on your conditional statement. And then for file I/O, we have statements like open and close to open and close files, read and write. We also have call and invoke. Call is for calling a subprogram. Invoke is for invoking a method in a class or a method on an object. And then another thing unique to COBOL is something called perform, and I will be talking about that. No other language has such a thing. Usually other languages break up executable units into functions, which you would call. And COBOL, you can actually perform parts of the code and use it in other ways as well, and it has much less overhead than a call statement. Then there's an exit statement, and there's even I have some of the latest COBOL standard, the 2014 standard, added exit perform cycle, which is really neat. And it reminds me that I meant to add an example of that in our COBOL example I'm going to show you, but I didn't. But anyway, so there's lots of different ways to leave your program or your section or your paragraph or whatever. And the exit perform cycle says, I want to skip this iteration of a loop and go to the next iteration without leaving the loop. I want to stay in the loop, but I'm done with this. If I'm on element number 30, I'm done with 30. I want to go to 31. So that's exit perform cycle. And we still have goto, and I say gag because gotos are awful. But it's kind of funny because my sample that I'm going to show you is a program that I wrote when I first joined IBM. In fact, I still remember in college hearing COBOL, but I misunderstood it. It was the business majors were walking by in the computer center, and I thought they were saying cobalt, like the governor of New Jersey said, because I had no idea that there was a programming language called COBOL. I was learning Fortran and PL1 in college. Then years later, I got hired by IBM to work on the COBOL compiler, and I thought, well, don't you already have a COBOL compiler? Why do you need to hire developers to work on a COBOL compiler? But I didn't know about new standards and adding things like AMOD 31 to a language that only supported AMOD 24, or making it truly reentrant. And then it's been nonstop in my 37 years of working on the COBOL compiler. Every day there's a huge backlog of things to do that we can't even keep up with. But when I first hired on, I didn't know COBOL, so I taught myself COBOL by writing a program to read a file of my weekly running mileage. I was a pretty avid runner for many, many years, and then to average it out and like get the average weekly mileage Is it weekly or daily? I'm going to have to look at the data and remind myself. I think it's weekly, and then I'd have averages at a bar graph that I was drawing. And so the reason I bring this up is I looked at this program. I thought this would be a great example because it has an input file and an output file, and I have it's all in a single job with the COBOL source and all these different things that I've been mentioning that I want to show you. But I noticed that I was using GoTo all over the place. My programming style was terrible. It was very embarrassing. I just finally noticed it this week. I've had this program forever, and I've been using it for testing things, but I haven't looked at the actual algorithm closely until I was thinking, well, I'm going to have to explain this today, so I better know it. And I looked at it, and I was just disgusted by how awful it was. So I rewrote it. So I'm going to show you my original go-to spaghetti code, and then using more modern features. Apparently, I didn't know about perform. When I taught myself COBOL, I didn't teach myself perform. I found enough statements to get my job done and went that way. And then over the years, I've learned a lot more. And I've seen a whole bunch of COBOL programs, including really nice ones and ugly ones. So you'll get to see both today. Okay, so that is my intro. Here's my, now this is a mainframe editor. The system is, Sudarsana, is my display working right? Everyone can see this, I hope?
Yes, we can, yep.
Excellent. Okay, so here is a job. So we can see at the top, we have a job card, it's called. Everything was cards in the beginning, so it's a job or job statement. And you can see my password here is very topical. So I have my username and a bunch of information about how much region size I want and the time that I'm going to allow this job to run. In case it gets an endless loop, I don't want it to endlessly loop for hours. I want it to only loop for, in this case, 29 seconds. I'm only giving it 29 seconds to run. And by the way, on mainframe, response is instantaneous, almost always. And I always notice this when I do Google searches or things on my smartphone, because they're very much slower than mainframes. Everything just happens so much more quickly with mainframes. It's incredible. Okay. All right, what else do we want to look at? Okay, so then the first chunk of work I have doing here is I'm deleting the old version of my output file called tmros.cbl.runout. So that's the graph that my COBOL program writes with my weekly running mileage graphed out in a bar graph. And I want to delete it each time so that when I run the program, I get a fresh one. So here's an exec statement with a title of COB on it. You can put little names on each statement. And the exec statement is executing a program called IGYCRCTL. And that is the name of the program that is the COBOL compiler. So the first thing my job is doing is running the COBOL compiler. And then I have a parm or a parameter so I can give it some options. And then I have a thing called steplib where I can point the job to a specific compiler. And my compiler is in a data set name, or DSN. DSN equals IGYV6R20.SIGICOMP. So that's telling the job which compiler to use, because there are many different versions of compilers, and especially since I work in compiler development, I need to point to different compilers all the time. In the real world, outside of IBM, customers normally just have a default compiler for all the users, and they don't have to do this. They can just leave out the steplib and just say exec program equals IGYCRCTL, and they'll get the one that's defaulting for all of the developers in that company. And then I have a bunch of these sysdd statements, like sysprint is the output file. So that says for the compile, sysout goes to asterisk, which means just put it right in the job stream, and I can show that to you. And then I have a bunch of work files, sysut 1 through 15. And then here's my COBOL program. You see up at the top here, cob.sysin. So that's my system input for the compile step is this COBOL program. And you can see the date that I wrote it, February 1983, way before a whole bunch of you were born. I put a comment in the top to say what the program is supposed to do, a graph which illustrates the weekly running mileage for a given runner, me. It reads in the runner's weekly running mileage and the date of the end of the week, and then prints the one character in a bar graph for each mile run. It also computes and prints the total mileage and average weekly mileage for each year and the test run year. Okay, I will show you the input and output for this program. I don't know when I should do that. I think I'll do it right now. Okay, so this is a different mainframe system. This other one, the editor is I like the editor on this system. This system is called VM, which is also a Z operating system, ZVM. And the editor is Xedit, and it's the best editor I've ever seen. This is ZOS itself. And it used to be called MVS, so you can see at the top the name of the system that I'm running on is called MVS1. So here's the output. I'm going to swap over to another screen and look at, here is the input data for my job. And you can see the name of we have a data set that has multiple members in it. In this one I have none data and run data for different runs. My data set is called tmros.cobol.data. We can see at the middle of the top. And it has different members in it. And I'm going to look at the member called run data with the edit command. Oops. And I thought I would, uh-oh. All right. Let's get out of here. Okay, so I thought E was short for edit, but unfortunately it wanted to bring up a new edit panel. I was going to be tricky and show you what E stands for, so I typed it out. Instead, I'm just going to do E, so that's what I would have done anyway, and it's E for edit. And then here's my data, and it's just a very simple text file with the date, March 28th, 1981. My weekly mileage for that week was 32, so I ran 32 miles that week, and then on down the line. And so then I just have many, many lines of raw data. It's numbers, but it's considered text because it's readable. So here's my text input file. And then I hit swap over to the output file. Well, we'll show that after. So in my program, I am going to show you how the program gets access to the input data. So I have a environment division. I forgot about that in the beginning. There's environment division, data division, and procedure division. The environment division defines some of the environmental things outside of the program. So I'm connecting, in this case, a file called run data in my program, and I'm assigning that to a file or a DD outside of my program called sysin s file1dd. So the DD name, the data definition name, is file1dd for the run data. And then for the output file, I have file2dd, and that's I'm going to assign an internal. The program is going to refer to the output file as graph. The outside of the program, it's called file2dd, and I'm going to skip to the bottom of my job and show you where we tell the program about those things. So if we look at there's 3 steps in this job: compile, link, and go. And this is the go step. And in this step, I'm executing, you can see another exec statement, and the program is my program, test run. And some of the things that go with the go statement are go dot things, like go dot seplib says, here's my runtime that I want to use. And my program is in tmros.cobol.load. So those Both of those things need to be available when I run. And then I have go.file1dd and go.file2dd. And these are the input and output files for my program. So this connects the DD name to the, DD name is actually outside the program. It connects the DD name to the actual data set name. So file1dd, my input is tmros.cobol.data, the member run data. And then the output file is not a partitioned data set. It's a single file by itself, and it's called tmros.cbl.runout. It doesn't have members. So there's different kinds of data sets on ZOS. And then I have other output things like go.sysout. This says, again, sysout asterisk says, put the output in my job output. I'm going to get a file back when I submit this job, and everything that's sysout asterisk will be in that output job. Okay, so now I'm going to go back up to the top. We looked at the environment division, where we define things, connecting things inside of the program to things that are outside the program. Then I have my data division, where I'm defining the file section and the working storage section. So first I'm going to have the file section, and I have my run data file with the records defined here. So we saw the raw data, the character, all those numbers that didn't really make any sense by themselves. But here I can see that I actually have month, day, year, and then the number of miles. And that's those different columns in the input file. So I will read one line of that file at a time, and then I can access the data on each line through these names in this file definition. The FD stands for file definition within my file section, within my data division. Okay, then I have my output file, which is a graph, so I call it graph. And I say the records are 131 bytes long, and the group. In COBOL, when you define data items, you can have a structure. In C, you would call it a structure. In COBOL, we call it a group, and the name of this group is bgraph, and it contains a whole bunch of different things. Another thing I'm just noticing now, I can take out filler. And that's the same thing, because all I'm doing is I'm just defining a placeholder. I don't want to use it. You can't refer to filler data items because it's not unique. But I can also leave it out, and that makes it much more readable. And I wish I would have done that, but there you go. So now if I take out the fillers, now you see the important things are the week, month, day. And then I have a header line and an average header line. So I have these kind of summary lines that I'm going to put out that I'll show you. Then we have my working storage section, where I define some variables. Run data FS, run data is my input file, graph is my output file, and there's things called file status. When I do something like an open or a write, the system will return a file status of whether it worked or not. And so I want to have access to that and check it. And I think I defined those higher up where, yes. So we can see here for run data, the file status data item is run data FS, run data file status. So then that's where I point the file to the data name, but the data name's not defined yet. Now here's where I define it. Run data FS is on this line here. If I make it current, and that's the file status for my my input file. Okay, and I have a bunch of other variables. Now we have the part of the program that actually has the real meat. These are the statements that do things, and it's called the procedure division. And then I have these things called section names. I can refer to those. I can perform them or go to them or leave a section. So you can see my sections. I have start it and loop and ILP1. And this is where I started looking at it yesterday, or the day before yesterday, and realizing, oh my gosh, this is the worst program I have ever seen, and I wrote it. So like right away, I do open input of the input file, and I have a period on it. And it is kind of true that it used to be that COBOL would have periods on every line, but modern COBOL, you try to avoid periods as much as possible. This is obviously not modern COBOL. This is a 1983 written by a guy fresh out of college who had no idea what he was doing, me. So I have periods everywhere. And then I test, so I open input, and then I test the file status to see if the open worked. Like, was the program able to find that file, and was it available, or was someone else using it, or does it not exist yet? If it doesn't exist, the system would say, you can't open that file, it's not there, and I would get a bad file status and not equal to 0. And then I would do, and normally I'd say perform, end the program, but I did a go to stop it here. And then I tested, opened the output as well, and tested that. Then I did a bunch of initialization, which I could have done much more easily. I could have said move 0 to total, tote weeks, and end pass with one statement, but I did each one separately. And then I write a blank line. I move spaces to bgraph. Bgraph is my output line, and then I write that output line. So I write a blank line to start my report, my output file. Then I do a loop where I process through all of the data that's in my input file. Read, run data, at end, go to. Go to. This program, I think, has like 12 go-tos in it, which was just shocking to me because we actually have features in the compiler that allow users to disable go-to in their shop. So I could be, like I'm Bank of America, or I'm Ford, or a government or something, and say we don't want any spaghetti bad coding that's hard to read in our shop. So don't allow our programmers to use go-to. But clearly I didn't set my compiler up that way, and I had lots of go-tos. Okay, so then here's my loop, but the loop is really hard to follow because I'm reading my run data, and I'm doing a bunch of work, getting the data out, like move the day to my day in my output record, add 1 to the total number of weeks, and then where is the return? Oh, at the bottom of the screen we can see go to loop. So go to loop is my loop, and then I have loops inside of it, and it's just awful. So I'm going to show you the better version, which I renamed this one to Job Old because it's very old, and the new one has much better style, I think. You can be the judge. I have the same name in the beginning, my section name. I do the startup stuff, open the files, etc. And then I have a paragraph called loop. Or, yeah, these are not sections, actually. These are paragraphs. If it said section, it would be a section. In my loop, I'm using perform. I actually put comments in here, too, like a better programmer would do. Loop through all the entries in the data file. So I have this, I'm calling it, and then I have the new, this is a 2002 standard comment style. The comments lines that are all asterisks, if you put an asterisk in column 7, then that whole line is just comments. There's no COBOL on that line. That's been the way of COBOL for many, many years. But more recently, we have the ability to say asterisk greater than, like where my perform forever is, and that's a comment on the same line as the perform statement. So I have a perform until, and then I have a matching end perform further down somewhere. And hopefully I'll get to put it all on the screen here. No. Okay, so there's the end perform for the perform forever at the top here. So this is the extent of my loop, and one of the things we'll notice is that none of these statements have periods on them. Periods are not required except in certain cases. For example, I have to have a period before a procedure name, a paragraph name. So in this within this perform loop, I have another perform loop down here. So first I'm going to put a blank, a single blank for each mile that I ran that week. And then I'm going to put an X for the to mark the actual the total number of miles for that week. So I have a loop for every every mile. I put a blank in my output bar, and I subscripted it with I. So I'm perform until I is greater than miles, greater than equal. Add 1 to I, and then move a blank into that field. And then I have another loop that clears the rest of the field because my work area has the data left over from the last line that I wrote. So I need to clear it out. Now I could have done this much more easily too. I could have just said move blank to the rest of the line, but for some reason I wrote a loop with gotos, and then to show you I did this with perform. So this I have the beginning of my perform here, and then the end perform, and that is my loop. So when I get to end perform with this looping, this perform until, it goes back up to the perform until the condition is met. When I is greater than 50, then I go past the end perform to the next statement in the program. And then I write the output line. And then if it's the end of the year, then I put out a header and say for that year, my weekly running mileage average was whatever. And then I have my paragraph to do the end of year header processing. So one of the things I can do with perform is say perform year header, and that's kind of like a go-to, except that it returns back here after it's done. So here's my year header paragraph. And why am I getting, there we go. Okay, make that the current line. So there's total in 19 whatever. So I have a year 2000 problem in this program where it's hard coding the 19 and then putting the year on the end. So I would go from 1999 to 1900. I didn't notice that before either. But I wrote the program in 1983, and we weren't quite thinking about the year 2000 problem yet. Plus, this program was just for me, so I didn't think that I would be running this program in 2020, that's for sure. Okay, so, and then if I get to the end of the pass, I want to show you that. When I get in my, while I'm reading through the input data, if I get to the end, so in my read statement, I have a conditional feature where I can say read run data. If I'm at the end of the file, so I'll keep reading records, and then at one point the system will say there are no more records, you're at the end. Then I would set end pass to true, and then perform the year header paragraph. And then if I get to year header and end pass is true, then in this if statement here, if end pass is true, then we perform the stop it paragraph, which closes the files and then does something called stop run, and that leaves the program, and so that leaves the COBOL program, which then the job terminates because that's the last thing in my job. So I can so this is the COBOL source. And that, I think I pointed out that, I told it to compile. Then I tell it to link edit, which says build an executable from the output of the compile. And then I tell it to go. And when it does all of these things and it finishes, then the job is complete and it returns to me. So I am going to, I took out the fillers, so I'll save that. I am going to, this is a list of all the files in my workspace here in VM. I'm going to submit this job. So I just use the sub command to submit test run job to my mainframe system. The file goes out, I get a notification that the file has gone out to the system. Then I get out of my file list, and I can see that I got something back from STL-MVS1. I got a reader file from the network. So then I would look at my input files, and here's the output I got from the job run with a whole bunch of stuff. So you can see at the top, it's a job log. JES2 is the system, job entry system, and it tells the name of the machine that I wrote on is called STL-MVS1. And then it has all of the things that happen in the job. And the first thing it did is it did that delete that I was telling you about. Delete the previous output file. And the return code, the condition code was 0. So it successfully deleted my previous running mileage bar graph. Then the next step in my job was to do a COB, or a COBOL compile, and that got a return code 0 as well. Then I did a link edit, and that got return code 0. And then I ran the program, the go step, and that also got return code 0. So everything was okay. Then I have a summary for my job at the end, and it says the highest return code from my job was 0. So that's good stuff. And then it has a bunch of stuff, JES2 job statistics, and I hardly ever look at that kind of thing unless I want to count like how long did it take to run, which I think I'm going to look at just for fun. Sometimes I run jobs where I perform a COBOL statement 100 million times in order to have enough time to measure, because if you run a statement one time, it doesn't take long enough to measure the amount of time it took. So if we make a change to something to improve performance, we have to execute it 100 million times or so to get enough CPU time to actually measure. So here is the, this is excellent. Okay, so I'm going to search for elapsed and show you the elapsed time of this job. The elapsed time was not long enough to count anything because it was just a short program, and the system runs so fast I didn't even see this. It says that it used 0 time. Oh, that's for the delete step, so it probably didn't take much time at all. Let's look at running my COBOL program. Oops. So that's the delete. Here's the COBOL step COB summary, how long the compile took. Again, it said it took 0 seconds. Link edit took 0 seconds. Oh, great, yeah. None of these steps took long enough to actually count seconds. Gosh, I'm sorry. I'm entertaining myself. The CPU for the go step is 0 hours, 0 minutes, and 0 seconds. Oh my gosh. This is not true, I have to say, in 1983. Here we go. Finally, the test run summary at the bottom took 1/100th of a second, of a CPU second, for the compile, link, and go, and start up, and end, and clean up, and everything. Gosh. Anyway, so I'm entertaining myself about how fast the mainframe is these days. When I first ran this, it would take a second or so to do some of the things, and now it doesn't, because the mainframes are getting faster and faster every year, so that now it's kind of ridiculous how much, like I was saying, when you hit enter to submit a job, before I can even go look at the output, it's already there. By the time my finger is up from pressing enter, it's done. Okay, so yeah, so when I do a Google search and it takes 2 seconds or 5 seconds, it kind of bugs me. Okay, so here is the compile output. So this is what the compiler's doing. If we look at, I'm going to search for enterprise. So we have a header that shows this is the compiler that I work on in IBM, Enterprise COBOL for ZOS. and I use 6.2. I could have used 6.3. That's the newer one. Then we see the actual program, and we get some messages for things like I got a message that a recording mode was not specified for my file, so it was assumed to be fixed, a fixed file as opposed to variable. Do I want to go to end of compilation? Sure, why not? End of range. Here's all the data items defined in my program, and I'm paging the wrong way. And so here's the summary of my program. I had two informational messages, return code 0, all was good. And then there's the link edit, output, and then the runtime. So you can see here in the middle, I'm highlighting output from the COBOL program was a display statement that said the graph file opened successfully. And that's all it did, except that it also wrote my new output file, cbl.runout. So this is what my program built. And so you can see I have put a number for each week on the far left. And then I have the date, March 28th, 1981. I ran 32 miles that week, and so I put an X in the 32nd column. And then the next week was a little bit less, 26 miles, and then 26, and then a little bit more. On the fourth week, 34. And so here's my bar graph. Now, it looks kind of weird being left to right, but back then you could print things on these long pieces of paper and turn it sideways, and then it would be more of a vertical, so the more mileage would be higher up. But from this view, it's further to the right. Okay, so then I have, I get to 32 weeks here. Let's go down 12 or so. And then, so then I only had 40 weeks of input, I guess. Interesting. Anyway, so then I had my, let's go to line 42. Find total. And then page down to that. So here's my summary lines that I wrote. At the end of the year, the total in 1981 was 563. Oh, I know what the problem was. In 1981, yeah, I didn't have all the weeks written down. And then I have the average per week in 1981 was 14 miles per week. Not that impressive. And then in 1982, I had 52 weeks of data, you can see, and I had a total was 1193 miles, and the average per week was 22.9. And then have each of the years, and then down to 1985. I stopped writing my running mileage in this file, so that's as far as it goes. It's the 25th week of 1985, but I had 579 miles with average of 23. So even if I didn't have all 52 weeks, I still got an accurate weekly mileage because I was dividing by the actual number of weeks. So we've looked at my the input file that I used with just a date of the end of the week and the weekly mileage, and then we had the output file that was created. We looked at the COBOL program. We looked at JCL. Here's a bunch of statistics for the job. I think that is everything that I wanted to cover. Sudarsana said that I should explain how I got the name Captain COBOL, so I will do that now. I have a coworker. He actually, yes.
Yeah, that's awesome. Yes, let's start with that, and then I just wanted to open up for questions as well to our participants. Put out your questions or on chat or Q&A, and we'll have Captain COBOL answer them for us. Yes, but
okay,
Tom.
So I have a coworker who works on some other ZOS system software. He actually works out of Perth, Australia, and we go to conferences and have a beer occasionally. And he had a friend ask him for COBOL help. And he said, well, I know just the guy. There's a guy, this Captain COBOL knows everything. And it just came off, spur of the moment. And then he told me about it, and I thought it was hilarious. So I put a sign on my door, and you can find me on LinkedIn and Facebook as Captain COBOL and stuff. So I thought it was hilarious. A lot of people called me Mr. COBOL before, and he said I deserved a promotion, and it cracked me up. And it's got the alliteration of Captain COBOL, so it's quite cool, I think. And you got to have fun in life, so I have fun with Captain COBOL. So that's how I got the name. So I didn't name myself that, but I gladly accepted the military promotion.
Absolutely, you earned it, right? So very, very cool story. Thank you, Tom. Any questions from our listeners today? Give me a second, Tom. I'm just quickly reading through Q&A. Okay. Yeah, there was one question about your thoughts on periodless programming, and I think you touched upon that already, right?
Yes.
Yeah. Okay.
Yeah, the danger, and I can say that the danger is that a period terminates everything that's unterminated. Like you could have nested ifs, like if then something, and then if then inside of that, and if then inside of that. So I'm 3 levels deep, and one period terminates all of the ifs. If I accidentally delete that period with bumping the space bar, I completely change my program, and it's kind of nutty. That should never happen, and it's hard to read. It's hard to see a period sometimes. You could have a speck of dust on your screen or something. So you should use end ifs instead. And so it was cracking me up that I've been a proponent of periodless programming for years, and then I look at my first program and it's got 7,000 periods in it.
We live and learn, don't we?
Mm-hmm.
Okay. So another question, would it be possible to extend the COBOL training and add some lessons about JCL? Okay, yeah. I think that's a question towards the actual COBOL course then, Micah? Yeah. If you could just put a chat back here. I just want to make sure I understand the context of the question as well. Yes.
Maybe
okay.
go more in depth into JCL.
Yeah, I think in the course content book that we've put out in Open Mainframe project, right, Tom, there as well. Certainly we can consider that. Thank you, Micah, for that suggestion. Let me go into our chat window, see if we have some questions there. Oh, there was a question about, is there a way for someone to be able to see, what are the upgrades or the features that have been added over the years to the COBOL compiler? Is that documented somewhere, Tom, that folks can get access to or read about?
Yeah, just got to make friends with me. No, seriously, it's not. Well, there's several answers to that. One is, I'm assuming we're talking about COBOL on ZOS. And for Enterprise COBOL for ZOS, we have a book called The Migration Guide. And in the front of it, it has a summary of changes to the COBOL compilers listed out by release. So you can see what was added in Enterprise COBOL 5.1, 5.2, 6.1, 6.2, and 6.3. And actually, I think it even goes back to version 4. So you can see release by release what the features were, the highlights. There's about a paragraph on each one. I also have a presentation that I give quite often because many mainframe customers have not moved forward yet. So they're still using Enterprise COBOL version 4, and now they're looking at going to version 6. And so one question is, how do you do that? And I talk about that all the time. And then once they're there, they want to know, okay, now that I have the new compiler, what's new in this compiler? I don't want to read a 400-page language reference manual to figure that out. And so I have a presentation where I have a bullet point for each of the new features. I mean, I could look at it here, maybe if we don't have other questions. or I can send it to you. So if you give us your email address, I will send this this file to you. It's a PowerPoint presentation, but I can create a PDF from it, and so it's a kind of a summary, a very short list. And then if you want more information, then you can look in the manual and say, okay, what the heck is JSON parse or JSON generate?
Okay, so if this is something we can share, I can work with you, right, Tom, and we can put it on our COBOL Hub resources page somehow, so folks can have access to that. We could do it that way too. I could work with you offline. Yeah, so
here's my presentation, but if we have time, we could go through it.
We are almost at the top of the hour, so I just want to see if we have other questions we can take. Okay. How different is JCL syntax from COBOL syntax? I mean,
wow.
Yeah, so I'm gonna.
Well, JCL has DD statements and exec statements, and COBOL has perform and procedure division and that kind of thing.
Yeah, so I think the follow-up question to that was, if we know COBOL, do we know JCL, or are they different?
Very different, completely
Yes, okay.
different things. In fact, you can write COBOL and run it without knowing JCL if you have someone else set up your systems for you. And there's a lot of software that does things like, here's my COBOL program, build my application, and now run it. And I don't have to know any of those details because the system, the software, we call them DevOps tools, development operations tools, can do all that for me. What I'm doing is an extremely manual system programmer kind of way to do it. But you don't actually have to know this stuff for every job on mainframe. You could be just a COBOL expert and write COBOL programs, and then someone else builds tools, and so you would just submit a command like, my program's ready, build it, and now run it. And it's as simple as that. But yeah, JCL is a whole language in itself, because it's completely separate from COBOL. JCL is unique to ZOS. COBOL is common across all platforms. You can have COBOL on Windows, COBOL on HP UX, or IBM has AIX operating system. So COBOL runs on every single platform in the world. JCL is only for ZOS.